back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 7.1, Solving Systems of Equations by Graphing. A couple of terms that you need to understand. A system of linear equations is two or more linear equations together. In terms of a graph, linear, if you remember, means line. So a system of linear equations on a graph would be two or more lines on the same graph. The solution of the system is any ordered pair in a system that makes all of the equations true. So again, if you're looking on a graph, it is where one point on the graph is touching all of the lines in the system. So if I have two lines, that one point has to touch both lines. If I have three lines, then that one point has to touch all three lines. We'll look at a couple of different special types of answers as we go through our notes today, okay? Let's get right into a problem. We're going to graph the two equations to determine the solution of the system. One thing that you need to remember about graphing that will help you immensely with systems is y equals mx plus b, where m is your slope and b is your y-intercept. To graph an equation that is in that form, we start at the y-intercept on the vertical y-axis, and then we move by the slope up and down in the numerator of the slope and right to left in the denominator of the slope. So remember that while we're going through these problems. There are some other forms that you could use to graph. However, we're going to concentrate on what this is, which is slope-intercept form. Slope-intercept form. So the first example, 1a here, that is already in slope-intercept form. So what you want to do is to go ahead and identify your slope, your m value. Remember, that's the number that's always attached to the x, which in this case is a 1, but we like to have it as a fraction so that we can use our idea of slope over here. So instead of just 1, it would be 1 over 1. My b value is this piece here, so 5. The point of my b value that I'm going to use then would be 0, 5. That's my y-intercept. So I go up to 5 on the y-axis. I move using my slope. So the numerator is 1. It means I go up 1. The denominator is 1, so I go right 1. Up 1, right 1. Remember, I also have to go in the opposite direction. So I go back to my y-intercept, which is 0, 5. Go down 1, left 1. There are my 3 points. Now, I do not want to make my line just yet. What I'm looking for in a system of equations is where the two lines meet. I want to find a point that is in both lines. So I'm going to leave it as those 3 points just for now until I get a look at what my other line is going to do. So I'm going to change colors for you here. 1b is not in slope-intercept form, so I need to go ahead and do that. The best way to explain to do that is to go ahead and solve for y. So I'll subtract 8x from both sides. 2y equals negative 8x plus 0 divided by 2 all the way through. Y equals negative 4x plus 0. Now, normally you don't have to write the plus 0, but since we are looking at slope-intercept form and that 0 would be my y-intercept, I'm going to keep it in there. So again, I'm going to identify my slope. My m is the negative 4 here, but I want to make it into a fraction, so negative 4 over 1. My b is 0. It's this right here. So I start at 0, 0, which is right in the middle. My slope tells me to go down 4, 1, 2, 3, 4, and right 1. The opposite direction for my slope, starting at 0, 0, is to go up 4, 1, 2, 3, 4, and left 1. What you'll notice is the point negative 1, 4, where I have the blue dot and the green dot together, is where my two lines are going to cross. Since I have a point where my two lines are going to cross, I can go ahead and finish my two lines. And my solution is going to be this point right here where my two lines cross. So my solution is going to be in an ordered pair, which means I need to use the x first. So I went over 1 and up 4. Please don't write those red lines. Please don't write those red lines. I'm just trying to show you where I'm moving and what I'm looking at. So my solution is -1, +4. X always comes first, y always comes second. My solution is -1, 4. All right, let's move on. In example 2, both of my equations are not in the correct form. So for 2a, I need to take it from point-slope form, which is what that is, into slope-intercept form. If you remember how to use point-slope form, you may be able to just use it from that point. But like I said, we're going to concentrate on slope-intercept form. So first thing I need to do is to go ahead and distribute. Y minus 4 then would equal -1 over 2x. -1/2 times 4 would get me a negative number, and half of 4 is 2. Now I can go ahead and add 4 to both sides. So y equals -1/2 x plus 2. My slope then is -1/2. My y-intercept is 2, meaning I start up 2. I go, the negative we always want to take it to the numerator to start with. So -1 means I go down 1 and then right 2. So I also have to start at my y-intercept and go up 1, left 2. For 2b, I'm going to change colors so you can match the equation to the line. All I have to do is subtract the 3x from both sides. So y equals -3x minus 3. I cannot combine the -3x and the -3 because the second -3 does not have an x value. So my slope would be -3 over 1. My y-intercept would be -3. Start down at -3. My slope tells me to go down 3, right 1. So down 1, 2, 3, right 1. I also need to go up 3, 1, 2, 3, left 1. Now, unlike our first problem, we have not found a point where our two lines will meet yet. So I need to continue one of my two lines at least out until I find that point where they will meet. So I'm going to continue my green line going up. So up 3, 1, 2, 3, left 1, and that's the point where they will meet. So I can now finish my lines. And my solution will be at the point where they have met, which is -2, +3. So my solution would be -2, +3. All right. Let's go ahead and move on to the back. Again, 3a and 3b are not in slope-intercept form. So the first thing I need to do is distribute. Y minus 3 equals 1/3 x. 1/3 of 6, basically 6 divided by 3, is +2. You can add 3 to both sides. So y equals 1/3 x plus 5, meaning my slope then is 1 over 3, and my y-intercept is 5. So I go ahead and start at +5, up 1, right 3, down 1, left 3. Again, don't complete your line until you know where they will cross, okay? Let's go ahead and look at the second equation. Again, subtract the x first. -6y equals -2x plus 12. Divide everything by -6. So y equals, well, -2 over -6, we want to keep it as a fraction, is going to end up 1 over 3. I don't want to turn it into a decimal because that is my slope, okay? And I really don't ever want to use decimals anyway. 12 divided by -6 would be -2. So my slope is 1 over 3. My y-intercept is -2. Now, if you remember anything about slopes when they're the same, you should know what's about to happen. If not, let's go ahead and look at this. So go start at -2. Tells me to go up 1, right 3. So up 1, right 3. Down 1, left 3. Uh-oh. They're moving exactly the same, so they're not getting any closer together. They're never going to meet, and they're never going to cross. So that means that these two lines are parallel. That's what I was talking about a little bit ago. If you remember what it means when both slopes are exactly the same, so 1/3 and 1/3, then you would know that these two lines were going to be parallel. If two lines are parallel, the only way to solve a system of equations is to have a point that works for both lines. Well, two lines that are parallel are never going to get closer together, and they're never going to touch, so they'll never have a single point that would work for both lines. So parallel lines means no solution. The answer I need from you is that this system of equations does not have a solution. And make sure that you finish out your lines even though they are not going to cross and that they are parallel. Make sure you go ahead and finish the lines. Okay? On to the last problem. Again, neither one of my equations is in slope-intercept form, so I need to turn it into slope-intercept form. Subtract the x value first. I'm not sure why that happened. So -3y equals -5x plus 9. Divide everything by -3. So y equals -5x over -3. Again, that's going to be my slope, so I want to keep it as a fraction. 5/3 cannot be simplified. Since there's a negative in the numerator and the denominator, it's going to turn into a positive. With positive 5/3x, 9/-3 turns into -3. Slope is 5/3. Y-intercept is -3. So I go up 5 and right 3. Meaning I should go down 5 and left 3. Okay, on to the second equation. The first thing I need to do is get rid of these parentheses, so I'll distribute. Y minus 7 equals 5/3x. 5/3 times -6. In order to work this, you're just going to multiply the 5 and the -6. The 5 and the -6 would get you -30/3. I'm going to leave 3 in the denominator. Now, -30/3 can be simplified. It will simplify into -10. If you are still struggling with fractions, multiplying fractions, adding fractions, subtracting fractions, simplifying fractions, please let me know and I can get you some additional material that can help you with fractions, okay? At this point, all I have to do is add 7 to both sides. So y equals 5/3x. Now, -10 plus 7 would be -3. So my slope, board's sticky, m equals 5/3. My y-intercept is -3. So I start at -3. That's the same place that I started with my other equation. I go up 5. 1, 2, 3, 4, 5. And right 3. 1, 2, 3. That's the same point from my first equation. If I go in the other direction, it's going to be the same point from my first equation. So what this tells me is my two equations are exactly the same. If they are exactly the same, then it will look like one line. Even though there's two different equations, they create the same line. If they are the same line, that means that every point possible on that line would satisfy both for A and for B for my system. So that means that I have an infinite number of solutions. So if both equations give you the same line, you have infinite solutions for a system of equations. All right? So what we're going to do now is talk about the three different types of solutions we found. If I have intersecting lines, I'll have one solution, and it will be in an ordered pair, x comma y. If I have parallel lines, I would have no solutions because it will never intersect, never touch, never cross, never get closer together. And if it's the same line, two equations that give you the same line, so it looks like it's one line, it would be infinite solutions. That is the end of our lesson. The biggest takeaways here are remembering how to use slope-intercept form, remembering how to manipulate an equation so you can get your equation into slope-intercept form, how to use slope and y-intercept, and what it means when you're looking at two lines on the same graph. Again, this bottom little chart basically covers what every different type that we looked at today means. If you have any questions on this, make sure you either email me or ask questions when you see me again. Otherwise, thank you very much for watching the video and have a great day.